Hello everybody, this is Vipul Purohit and you are watching my YouTube channel. Now in the previous video, I had explained you about the basics, the essentialities of molecular orbital theory. Now in this video, we are going to discuss about the applications. We are going to apply this molecular orbital theory to the most simplest, and that is homonuclear diatomic molecules. Right, so we are going to apply this molecular orbital theory to this homonuclear diatomic molecules. So before we actually start applying it, let us first of all understand homonuclear diatomic molecule hota kya hai, what exactly it means. Okay, homo means the same, nuclear means it's related to the nucleus, diatomic molecules. जैसे आपको पहले वीडियो में भी मैंने बताया था कि molecule is formed by combination of atoms. And when I use the word combination, so it's very obvious that there has to be at least two. And the simplest molecule is the one which contains two atoms. तो हम ये वही simple molecule की बात कर रहे हैं यहाँ पे जहाँ पर दो atoms हैं. लेकिन अभी homonuclear है. अभी homonuclear है, इसका मतलब ये हुआ कि both the atoms are of the same elements. Alright? So what is the simplest meaning of this homonuclear diatomic molecule is, we are talking about a molecule which is made up of two atoms of the same element. That is what is the meaning of homonuclear diatomic molecule. Molecule which contains of two atoms, and therefore it is the simplest molecule. I cannot have a molecule with one atom. Then what is the difference between a molecule and an atom? Okay, यानी कम से कम दो एटम होना जरूरी है, और यहाँ पर हम वही दो एटम के बारे में बात कर रहे हैं, और वो भी वापस सेम एलिमेंट के है. ओके, इसलिए हमने इसको होमोन्यूक्लियर बोला. अगर हेटेरोन्यूक्लियर होता तो यहाँ पर क्या हो जाता, सेम की जगह पर डिफरेंट हो जाता. सो टू एटम्स ऑफ डिफरेंट एलिमेंट्स, बट यहाँ पर वी आर गोइंग टू टॉक अबाउट टू एटम्स ऑफ द सेम एलिमेंट. नेक्स्ट पार्ट इज which type of molecules are we going to discuss, and that is we are going according to the atomic numbers. So atomic number 1 से लेकर atomic number 10 वहाँ तक हमें डिस्कस करना है. So that means मैं बताना चाहूँगा आपको, पहला है हाइड्रोजन H2, second is helium, that is He2, next one is Li2, next one is Beryllium 2, next one we have is B2, boron, next we have is C2, next we have is N2, next is O2, next is F2, and the last one is Ne2. Okay, so these are the molecules that we are going to consider as a part of applications of molecular orbital theory. And all these, you can check it out, everywhere there are going to be two atoms, so it is diatomic, and everywhere both the atoms are of the same elements, and therefore it is homonuclear. Alright? Okay. Now before we actually start with the application part, okay, I'm going to give you some basic ideas about of some concepts. The concept number 1, and that is bond order. Now generally, okay, I'm using this word generally, my dear friends. Okay, they are the number of covalent bonds which are present in a molecule. Okay, exceptional cases are there. Okay, but then what is the word I'm using? Generally. So generally, the number of covalent bonds present in a molecule is given by means of what? Bond order. Now it's a number. So obviously when you talk about a number, तो कहीं ना कहीं calculations आएगा, कुछ formula आएगा, और वो formula मैं आपके सामने बताना चाहूँगा, और वो ये है कि bond order is equal to half into NB minus of NA. Now what does NB and NA stands for? Alright, and that is, first thing is, why this half? Because generally the bonds are going to be formed between two species. Okay, so that's why we consider that. And the next part is NB and NA, both of them are involved in the process of bond formation. इसलिए हम लोग ने यहाँ पे 2 कंसिडर किया है. ओके, दोनों, एक है for और दूसरा है against, but then they are involved in the part of the process. ओके, ये आप भूलना मत. ऐसे मत बोलिए कि सिर्फ bonding is involved in the process. No, whenever we talk about involvement, ओके जब भी कोई एक डिबेट होता है, कोई डिसीजन लेना होता है, तो वहां पर जो इन्वॉल्व होते हैं वो क्या होते हैं, एक पार्टी ऐसा होता है जो फॉर के बारे में बोलेगा और द अदर वन इज अगेंस्ट. Okay, so we are not going to say that, okay, those who are saying against, they are not involved at all. They are also involved in this particular discussion. The same thing is over here. The bonding as well as anti-bonding, both of them are involved in this process of bond formation, and therefore we are going to consider it as half. Next thing is, we always go for stability because chemistry is all about stability, and therefore we always give priority towards bonding, and therefore the formula is Nb minus Na. It's not Na minus Nb, it is Nb minus Na. Or minus sign Q, that I guess you understood, and that is because both of them are opposites. Bonding and anti-bonding are opposites, so therefore it is minus. Now the most important question is, what is Nb and Na stands for? Yes, Nb stands for the number of electrons, okay, which are present in the bonding molecular orbital. Na stands for the number of electrons in the anti-bonding molecular orbital. Okay, bonding is related to strength, stability, so obviously the electrons will have a tendency to go towards bonding. Okay, if the bondings are completely filled, then the electrons will go in what? Anti-bonding, and therefore the first is bonding and the next part comes as anti-bonding. अब यहाँ पे दोस्तों याद रखिएगा, most important is, many times what the students feel is Nb means number of bonding molecular orbitals and Na means the number of anti-bonding molecular orbitals. That's wrong, my dear friends. Okay, because in most of the cases, okay, the number of bonding molecular orbitals and number of anti-bonding molecular orbitals are same. So the answer will come out as 0. Okay, so bond order 0. ऐसा हो जाएगा. What is bond order? Number of bonds. So number of bonds are 0. Molecule cannot exist without a bond. I'm very sure you understand this. There is not a single molecule without a bond. तो अगर bond ही नहीं है तो molecule ही नहीं है. Okay, ऐसा हो जाएगा फिर. इसलिए please ध्यान रखिएगा. Okay, Na और Nb, what does it stands for? Okay, it stands for the number of electrons. Okay, in that particular orbital. So it is number of electrons in VMO and it is the number of electrons in AVMO. Okay, so please be very particular with respect to this. Okay, so this was about the concept of what? Bond order. One more point which I want you to understand before we actually start with the application process, and that is the magnetic properties. Now magnetic properties are related to arrangement of electrons. Okay, electrons की जब हम arrangement की बात करेंगे तो दो तरीके का arrangement होता है. एक होता है that is single, दूसरा होता है pair. Okay, now if it is going to be single, okay, so that means उसका एक spin motion होगा. Okay, that is either clockwise or anti-clockwise. Again, if it is paired, then the spin motion gets cancelled because one is clockwise and the other is anti-clockwise. And this particular phenomenon is related to its behavior in presence of a magnetic field with respect to attractions as well as repulsions. अगर वहाँ पर spin motion है, so there will be a spin magnetic moment. Okay, and as a result of it there will be attraction. लेकिन अगर spin motion cancel हो गया है, so magnetic moment वहाँ पर नहीं है, so there is no attraction, there is going to be what? Repulsion. तो ये याद रखिएगा. So magnetic properties में when we talk about the presence of single electrons, we say it is paramagnetic. And when all electrons are paired, we say it is diamagnetic. Alright, I'm using this word all because it's very important. Many times what happens, if I'm going to show an orbital like this, and if I'm showing electrons in this way, and if I ask a question, come and tell me whether it's paramagnetic or diamagnetic, some of the students say it's paired electrons, so that means it is diamagnetic. Okay, तो ये confusion ना हो इसलिए मैंने यहाँ पे कौन सा word use किया है? All. सारे के सारे इलेक्ट्रॉन जोड़ी में होने चाहिए तो ही वो डायमैग्नेटिक होगा, वरना नहीं होगा. याद रखिएगा. तो ये क्या है? पैरामैग्नेटिक है because of the presence of what? Single electrons. Okay, that is going to make it as what? Paramagnetic. तो ये बात याद रखिएगा. तो अगर मैं यहाँ पर एक पेयर और कर देता हूँ like this, तो भी ये क्या रहेगा? पैरामैग्नेटिक, क्योंकि सारे के सारे इलेक्ट्रॉन्स जोड़ी में नहीं है. ओके, अभी मैं अगर ऐसा कर दिया, yes, now it becomes what? Diamagnetic, because now all the electrons are paired. So in this way, with reference to the arrangement of the electrons, we can also comment on the magnetic properties. तो पहले तो electrons का distribution कैसे हुआ है in bonding molecular orbital as well as anti-bonding molecular orbital. We can come to know about bond order using this particular formula. Bond order is equal to half into Nv minus of Na. And how the electrons are arranged, whether they are single or paired, accordingly we can comment कि क्या वो molecule diamagnetic है या फिर वो paramagnetic है. Okay? तो ये दो मुझे basic concepts आपको explain करने थे, so that you know when I start with the application of this molecular orbital theory with respect to these molecules, it becomes very easy for you. So I'm sure you have understood up to this very well. Yes, my dear friends, now once you have understood the basic part about the application, which molecules are we going to consider in this particular video with respect to the molecular orbital theory, then I've also explained you about what is bond order and then about magnetic properties. So we start the application part of molecular orbital theory. Now see, total 10 molecules has to be considered from hydrogen till neon. So what I want to make you understand is in the most simplest manner, because that is always my priority. I will be dividing these molecules into 3 parts. Okay? Because it sounds to be very much high. 10 molecules पढ़ना है, बाप रे. लेकिन है बहुत easy. और इसको easy करने के लिए मैं ये 10 molecules को part में divide करता हूँ. कितने parts में? 3 parts में. Okay? First part, 4 molecules. According to the atomic number. So hydrogen, helium, lithium, beryllium. Okay? Second part, we are going to talk about 3 molecules. Atomic number 5, 6, 7. मतलब boron, carbon and nitrogen. And the last part, and 3 molecules. Oxygen, fluorine and neon. Okay? Now, what is the speciality about all these parts is? So now the number is reduced. Which we initially I told you that we need to learn 10 molecules, so now we have to learn into 3 parts. And in these 3 parts, okay, learn the first molecule very well. The remaining molecules becomes very easy. थोड़ा सा changes करना है बस. और वो मैं यहाँ पर दिखाऊंगा भी. Okay, कई बार क्या लगता है कि आपको ऐसा लगता है कि हाँ टीचर ऐसा बोलता है, हमें झूठा दिलासा देता है वो. लेकिन ऐसा नहीं है. मैं यहाँ पे practically live दिखाऊंगा कि जो क्या minimum changes करना है. And accordingly आपको second molecule मिल जाता है. Accordingly आपको third molecule मिल जाता है. Okay? तो मैं जो बात कर रहा हूँ उस पर आपको belief होगा. Okay? आप उसको यकीन मानोगे. तो पहला मॉलिक्यूल हर एक ग्रुप का 3 पार्ट का मैंने जैसे बोला है, तो हर एक 3 पार्ट का पहला मॉलिक्यूल अगर समझ में आ गया तो बाकी का मॉलिक्यूल उस पार्ट का बहुत इजी है, क्योंकि जो मैं यहाँ पर आपको उस तरीके से पढ़ाऊंगा. ऑलराइट, सो वी स्टार्ट विद द फर्स्ट पार्ट. और फर्स्ट पार्ट में कौन से मॉलिक्यूल्स है, और वो है हाइड्रोजन है. फिर सेकेंड मॉलिक्यूल कौन सा आएगा, हीलियम. फिर तीसरा कौन सा आएगा, लिथियम. और चौथा आएगा बेरिलियम, Be2. ओके, दिस इज द पार्ट 1. ऑलराइट, तो हम पहले शुरू करेंगे हाइड्रोजन मॉलिक्यूल से. ओके, वी आर गोइंग टू स्टार्ट विद हाइड्रोजन मॉलिक्यूल. Formula is H2. Now the entire part I'm going to explain in terms of 7 points. Okay, and those 7 points are common everywhere. Okay, सब जगह क्या है, common है, तो आपको कोई टेंशन नहीं. Okay, only thing is the explanation under those points will differ as we change the molecules. Alright, so we begin with first point of the first molecule, and that is hydrogen molecule. Electronic configuration. Okay, of course we are going to consider the valence shell electronic configuration of the combining atoms. Okay, electronic configuration of the combining atoms. So here we are going to talk about hydrogen. Atomic number is 1, so its electronic configuration is 1s1. The second one also is hydrogen because it is homonuclear. तो दो बार लिखने की कोई जरूरत नहीं है, ओके, एक ही बार लिखना इट्स इनफ। ये दूसरा एलिमेंट भी हाइड्रोजन ही है, ओके। तो ये हो गया पहला पॉइंट, इलेक्ट्रॉनिक कॉन्फ़िगरेशन ऑफ द कंबाइनिंग एटम्स में हाइड्रोजन दिखाना, एंड इसका इलेक्ट्रॉनिक कॉन्फ़िगरेशन एवरीबॉडी नोज इट इज 1s1। नेक्स्ट point number 2, and that is we are going to discuss about the overlapping of atomic orbitals, because you know very well in my previous video I have already explained you that how the molecular orbitals are formed. Yes, it is by means of overlapping of atomic orbitals, okay। molecular orbital theory का part 1 वाले वीडियो में मैंने वो ऑलरेडी बता दिया है, ओके। और इस वीडियो के डिस्क्रिप्शन में भी आपको वो molecular orbital theory part 1 का लिंक मिल जाएगा, ओके। तो अगर आपने वो मिस किया है तो प्लीज वो एक बार देख लीजिएगा, ओके। सो यहां पर वी आर गोइंग टू टॉक अबाउट ओवरलैपिंग ऑफ एटॉमिक ऑर्बिटल्स। आई जस्ट राइट डाउन इन शॉर्ट एटॉमिक ऑर्बिटल्स, ओके। सो व्हाट यू आर गोइंग टू राइट डाउन इन दिस केस इज हाइड्रोजन है, एक ही ऑर्बिटल है, दैट इज 1s, सो नो टेंशन एट ऑल। सो 1s ऑर्बिटल ऑफ द टू हाइड्रोजन एटम्स overlap, resulting in the formation of two molecular orbitals. In my previous video I have already explained you that the number of atomic orbitals involved in combination, same number of molecular orbitals are formed. So 1s orbital of two hydrogen atoms are overlapping, यानी कितने टोटल ऑर्बिटल्स हो गए? दो। 1s एक हाइड्रोजन का, 1s दूसरे हाइड्रोजन का, टोटल कितना हो गया? दो। तो दो अगर एटॉमिक ऑर्बिटल्स शामिल है ओवरलैपिंग में तो कितने मिलेंगे? दो मॉलिक्यूलर ऑर्बिटल, लेकिन उनका एनर्जी लेवल अलग अलग है, ये मैंने आपको पहले भी बताया था। हाफ ऑफ देम इज बॉन्डिंग, द अदर हाफ इज एंटी बॉन्डिंग। ऑल्सो आई हैड एक्सप्लेन्ड इन द प्रीवियस वीडियो दैट s ऑर्बिटल्स, सो दैट मींस इट विल ऑलवेज रिजल्ट इन सिग्मा, ओके। तो एक बॉन्डिंग होगा और एक एंटी बॉन्डिंग होगा। एंटी बॉन्डिंग इज मार्क्ड बाय मींस ऑफ स्टार। तो इस तरीके से द टू मॉलिक्यूलर ऑर्बिटल्स दैट वी गेट विल बी sigma 1s and sigma star 1s। तो इस तरीके से we will be getting the two molecular orbitals, one bonding and the other is anti-bonding। Alright, done with this? Alright, next thing is, एक बार molecular orbitals बन गया, फिर क्या होगा? Electrons arrange होगा। So the point number 3 we go for is distribution of electrons in the molecular orbital. That is the next point, distribution of electrons in the molecular orbital। तो कितने इलेक्ट्रॉन्स हमें अरेंज करना है, दैट इज मोर इंपॉर्टेंट, ओके। एक हाइड्रोजन का एक इलेक्ट्रॉन, सो दो हाइड्रोजन के दो इलेक्ट्रॉन। सो वी हैव टू अरेंज टू इलेक्ट्रॉन्स in these two molecular orbitals, sigma 1s and sigma star 1s। But then, my dear friends, there are some rules. What is the rule is? And that is, in chemistry we always give priority for what? Stability. And who is more stable? Sigma 1s, because it is bonding. Okay, तो ये याद रखिए, यानी electron filling will always start from sigma 1s, मतलब bonding molecular orbital से। Okay, next thing is, every molecular orbital has a capacity of 2 electrons। कितना कैपेसिटी है? 2 इलेक्ट्रॉन्स का, ठीक है। यानी इसमें 2 इलेक्ट्रॉन जा सकते हैं, इसमें 2 इलेक्ट्रॉन जा सकते हैं, यानी टोटल 4 इलेक्ट्रॉन्स अरेंज कर सकते हैं। लेकिन वी हैव टू अरेंज हाउ मेनी इलेक्ट्रॉन्स? 2 इलेक्ट्रॉन्स, ओके। वन है m+1 मोड ऑफ द अनदर हाइड्रोजन, ओके। तो कैसे करेंगे? तो एक तो समझ में आया कि स्टार्टिंग कहां से करना है? फ्रॉम द बॉन्डिंग मॉलिक्यूलर ऑर्बिटल। द सेकंड रूल इज, electron will not go to the higher energy level till the previous lower energy level is completely filled। एनर्जी ऊपर वाले मॉलिक्यूलर ऑर्बिटल में तब तक नहीं जाएगा जब तक नीचे वाला पूरा का पूरा भरा हुआ नहीं है। समझ में आया? यानी पूरा का पूरा भरा हुआ मतलब कितना? 2 इलेक्ट्रॉन। यानी सिग्मा स्टार 1s में इलेक्ट्रॉन तब तक नहीं जाएगा जब तक सिग्मा 1s में कंप्लीटली फिल्ड नहीं है, मतलब कितना? 2 इलेक्ट्रॉन, और मुझे 2 इलेक्ट्रॉन ही अरेंज करना है इन दिस हाइड्रोजन मॉलिक्यूल। यानी इसका मतलब क्या हो गया? जो 2 इलेक्ट्रॉन मुझे अरेंज करना है इन दिस हाइड्रोजन मॉलिक्यूल, बोथ द इलेक्ट्रॉन्स आर गोइंग टू बी ऑक्यूपाइंग सिग्मा 1s, and in other words sigma star 1s will be vacant। You getting it? Okay, so that is what we are going to say। So distribution of electrons में what we are going to say is both the electrons occupy sigma 1s. Okay, and sigma star 1s is vacant. यानी ये दो रूल याद रखना है. First, electron filling will always start from the lower energy molecular orbital. और दूसरा रूल, electron will not go to the higher energy level till the previous lower energy level is completely filled. ठीक है? Alright. तो ये था distribution of electrons in molecular orbitals. Next part, we talk about electronic configuration. लेकिन किसका अभी? मॉलिक्यूल का. तो दो इलेक्ट्रॉन्स किधर गए? सिग्मा 1s में गए. So therefore the electronic configuration will be sigma 1s2. Okay, ऐसा लिखना है. Okay, we have a sigma 1s2. अब देखिए दोस्तों, electronic configuration यहाँ पर भी मैंने लिखा है. Electronic configuration I've written over here also. So if you can compare, you will find out that there is one symbol which is there in the molecular electronic configuration, but it's not there over here in atom. And what is that? Yes, you got it. Sigma. Sigma stands for a bond, and bond is always present in a molecule, and therefore this is the electronic configuration of the molecule. और वो सिग्मा इधर नहीं है क्योंकि ये इलेक्ट्रॉनिक कॉन्फ़िगरेशन किसका? एटम का है. ओके, इसलिए वहां पर मैंने सिग्मा नहीं लिखा है. ओके, तो इस तरीके से फ्रॉम द इलेक्ट्रॉनिक कॉन्फ़िगरेशन यू कैन आइडेंटिफाई कि किसका वो एटम का इलेक्ट्रॉनिक कॉन्फ़िगरेशन है या फिर वो मॉलिक्यूल का इलेक्ट्रॉनिक कॉन्फ़िगरेशन है. दिस इज व्हाट इज द सिंपलेस्ट वे टू आइडेंटिफाई, okay, by means of these symbols. Okay, so this was about electronic configuration. So this is point number कितना हो गया? 4. Okay, point number is 4. Point number 5, and that is we talk about bond order. I have already explained you. Okay, what is bond order is? Okay, so bond order का formula आप जानते ही हो. It is half into Nb minus of Na. So it is equal to half into number of electrons in bonding minus number of electrons in anti-bonding. So bonding में कितने electrons है? 2. Anti-bonding में भी नहीं है. Okay, it is vacant. So 2 minus of 0. So that is equal to what? 1. Okay, half into 2 minus of 0 is equal to 1. So therefore, what we say is there exists a single bond between the two hydrogen atoms. Single bond between the two hydrogen atoms. Alright, this is about the bond order. Next thing is, we go into magnetic properties. So in this case, when you talk about a magnetic property, as I already explained you, and that is, it is related to the arrangement of the electrons. Again, electron single है, so it is paramagnetic. If the electrons are paired, so that means it is diamagnetic. Alright? So here, when you talk about electron, it is going to be what? Single or paired? So it's paired. Okay, and you don't have any single electron. When all electrons are paired, that means the molecule is what? Diamagnetic. So all electrons are paired, and therefore we say it is diamagnetic. Okay, that means when it is placed in a magnetic field, it is going to experience a force of repulsions. Alright, so this is point number 6. 1, 2, 3, 4, 5, 6. Total I told you 7 points. 7वां point भी है दोस्तों, बहुत important है वो, and that is the molecular orbital diagram. Okay, लेकिन मैं बाद में बताऊंगा. First of all, I want you to understand this 6 points. The first point is electronic configuration of the combining atoms. We are talking about hydrogen molecule at the moment. So it is 1s1. Overlapping of atomic orbitals. 1s orbital of the two hydrogen atoms are going to overlap, so resulting in the formation of two molecular orbitals, that is sigma 1s and sigma star 1s. Distribution of electrons. 2 इलेक्ट्रॉन मुझे अरेंज करने हैं. 1 इलेक्ट्रॉन पर हाइड्रोजन एटम, तो 2 इलेक्ट्रॉन किधर जाएगा? सिग्मा 1s में. और इससे इलेक्ट्रॉनिक कॉन्फ़िगरेशन क्या हो जाएगा? सिग्मा 1s2. बॉन्ड ऑर्डर की बात करें, फार्मूला मैंने आपको ऑलरेडी बताया. इट इज हाफ इनटू द नंबर ऑफ इलेक्ट्रॉन्स इन बॉन्डिंग माइनस एंटी बॉन्डिंग. सो 2 minus of 0, it comes out to be what? 1, and therefore we say that there exists a single bond between the two hydrogen atoms. Both these electrons are paired. Okay, and because of that we say it is diamagnetic. Okay, this is magnetic property. That is point number 6. अब दोस्तों मैं उस पार्ट पर आता हूँ। मैंने क्या बोला था आपको? When you consider a particular part, okay, I am going to divide the 10 molecules in 3 parts, right? So when I am going to divide, okay, into 3 parts, so when I consider the first part and when I consider the first molecule, when I consider what? The first molecule of that particular part, so if you understand that, the other part becomes very easy. तो बाकी के जो पार्ट है वो बहुत इजी हो जाते हैं फिर, ओके? जैसे कि ये पार्ट में हम लोगों ने क्या कंसीडर किया? हाइड्रोजन मॉलिक्यूल। देखो यहाँ पे मैंने लिखा है पार्ट 1 हाइड्रोजन मॉलिक्यूल। अगर आपको हाइड्रोजन मॉलिक्यूल अच्छी तरीके से समझ में आया, ये 6 पॉइंट्स, 7 पॉइंट इज पेंडिंग, आई नो दैट, ओके? मॉलिक्यूलर ऑर्बिटल डायग्राम बताऊंगा मैं आपको, लेकिन पहले ये 6 पॉइंट्स का क्लियर कर लेते हैं। सो इफ यू हैव अंडरस्टूड हाइड्रोजन with respect to the 6 points, then with minimum amount of changes, you will understand the remaining 3 molecules also, helium, lithium and beryllium. Minimum changes has to be done for this. और मैं आपको ये लाइव बताऊंगा, ओके? नहीं तो मैंने जैसे बोला था आपको, कई बार यकीन नहीं आता स्टूडेंट्स को, ओके? तो ये मैं आपको लाइव बताऊंगा कि किस तरीके से थोड़ा सा चेंजेस करेंगे किसमें? हाइड्रोजन मॉलिक्यूल, तो हमें मिलेगा हीलियम। चेंजेस करेंगे हमें मिलेगा लिथियम, चेंजेस करेंगे हमें मिलेगा बेरिलियम। माइनर चेंजेस, ओके? और ये लाइव आप देख सकते हो, मैं हाथ में ये डस्टर रखता हूँ ताकि आपको समझ में आएगा कि कौन सा माइनर चेंजेस कर रहा हूँ, पूरा का पूरा नहीं, ये सब पूरा स्ट्रक्चर सेम है, ओनली द माइनर चेंजेस एंड यू गेट द आंसर, ओके? सो इस तरीके से यू हैव टू लिंक one molecule to another. और केमिस्ट्री की पढ़ाई ऐसे ही होती है. This is the way to learn chemistry, and that is you start linking one concept to the another, and then see you start understanding that concept, and of course you start liking that subject also. ठीक है? So we begin with the next molecule. और वो next molecule कौन सा है दोस्तों? Yes, it's the helium molecule. All right. So in this case, the changes which I'm going to do is, okay, hydrogen now becomes what? A helium molecule. So now here it will be He2. So point number 1 is electronic configuration of the combining atoms. So here we are going to write down as He, and this is 2. So what will happen over here is it will become 1s2. Okay? Now overlapping of atomic orbitals, obviously it is 1s only. So 1s orbital of the 2 hydrogen atom overlaps, results in 2 molecular orbitals, sigma 1s and sigma star 1s. Okay, no change. Distribution of electrons. Now see, we have 2 electrons per helium. So how many helium are over here? 2 helium. So 2 and 2 is how much? 4. Okay, so 2 electrons will go in sigma 1s. मैंने ये रूल आपको पहले ही बता दिया था। अब बाकी का 2 किधर जाएगा? Yes, sigma star 1s. So both the electrons, okay, or else what we say is, हम यहाँ पे थोड़ा सा changes कर देते हैं, और वो है कि 2 electrons occupy sigma 1s and sigma star 1s. Okay, this is the way we do it. Electronic configuration of the molecule में फिर क्या करना है? Sigma 1s2 and then we are going to make it as sigma star 1s2. Okay, this is the way we are going to make it. ठीक है? देखा आपने क्या क्या माइनर चेंजेस हो रहा है? बॉन्ड ऑर्डर हाफ इंटू Nb माइनस ऑफ Na इज इक्वल टू हाफ इंटू 2 माइनस ऑफ, अब ये 2 इलेक्ट्रॉन्स एंटी बॉन्डिंग में गया है, so 2 minus of 2, so it gives you what? 0. The bond order is 0, my dear friends. A bond order 0 है मतलब bond ही नहीं है. A bond नहीं है तो there is no molecule, and therefore now what am I going to write down is therefore He2 molecule does not exist. Okay, He2 molecule does not exist because the bond order is 0. Now when you come for magnetic property, this hardly has any relevance. बहुत हार्डली उसका इंपॉर्टेंस है ये पर्टिकुलर स्टेटमेंट का, क्योंकि जब मॉलिक्यूल ही एग्जिस्ट नहीं करता है तो फिर उसके मैग्नेटिक प्रॉपर्टीज के बारे में क्या चर्चा करनी है. Okay, we are going to discuss only about those which exist. Those who do not exist, why do we need to make a mention about it? So this statement hardly has any relevance. Okay, the electrons are paired. Yes, of course, the electrons are paired in this molecule and they are diamagnetic. But the molecule does not exist at all. Okay, so this one particular point is not very important, relevant with respect to helium. Okay, तो आपने देखा होगा कि कितना माइनर चेंजेस किया है मैंने, जो ओके आपके सामने मैंने लाइव डेमोन्स्ट्रेट करके दिया है. मैंने हाइड्रोजन मॉलिक्यूल एक्सप्लेन किया था और फिर इस डस्टर की मदद से मैंने थोड़ा माइनर चेंजेस किया और आपको ये पूरा हीलियम का मिल गया होगा. ओके, तो आप एक बार नजर घुमा सकते हो विद रिस्पेक्ट टू हीलियम, सो दैट यू अंडरस्टैंड दिस हीलियम आल्सो वेरी वेल. एंड देन मैं आपको उसी तरीके से थोड़ा सा माइनर चेंजेस करके मैं लिथियम और बेरिलियम के बारे में भी बताऊंगा. ऑलराइट, सो आई थिंक यू हैव अंडरस्टूड दिस पार्ट वेरी वेल, एवरी वन ऑफ यू. Okay, so we now move on to the next molecule. Okay, and that is, we talk about the lithium molecule. Okay, lithium, it will become Li2. So here there will be a change now, and that is lithium. Atomic number, you know, it is 3. Now one changes. And that is, we are not going to write down the electronic configuration right from 1s, because आप जानते हो अच्छी तरीके से only the valence electrons okay play a role in bonding. So what we do now is, we are only going to write down the valence orbital, and that is 2s1. So that means there is only one electron that we are going to consider for lithium. ठीक है? Next, overlapping of orbitals. तो अभी यहाँ पे 1s की जगह पर क्या आएंगे? 2s. 2s orbital of the two lithium atoms overlap, resulting in the formation of two molecular orbitals. So this will be sigma 2s and this will be sigma star 2s. ठीक है? That way it will be. Distribution of electrons, one electron per lithium, so two lithium, two electrons, so both the electrons will go in what? Sigma 2s. So we are going to say both electrons occupy sigma 2s. That's it. Okay, both the electrons occupy what? Sigma 2s. Electronic configuration, no need for this sigma star. Instead of 1s, I'll make it as 2s. Alright, so it will give me sigma 2s2. Bond order half into Np minus of Na, so it is half into 2 minus of 0. So therefore, we'll say here the answer comes out to be 1, and therefore we say there exists a single bond. Between the two lithium atoms. And the magnetic property, of course, all the electrons are paired and therefore it is diamagnetic. Alright? So see this once again, some minor changes and we got what? Lithium. Okay, अभी आप इसको रिलेट करने की कोशिश करोगे तो आपको ये समझेगा हाइड्रोजन एंड लिथियम आर एग्जैक्टली सेम. ओके, सिर्फ एक ही चेंज करना है, वो क्या है? इन केस ऑफ हाइड्रोजन इट वाज 1s, इन केस ऑफ लिथियम इट इज 2s. ओके, उतना ही फर्क है, बाकी एवरीथिंग इज सेम, ये आपको पता चलेगा. सो प्लीज हैव अ लुक एट द लिथियम मॉलिक्यूल एंड देन वी कैन प्रोसीड टू द नेक्स्ट मॉलिक्यूल दैट विल बी बेरिलियम. सो प्लीज हैव अ लुक एट इट. Alright, now we go to the last molecule of this part, and that is we talk about beryllium. It will be Be2. Beryllium atomic number will be 4, so its electronic configuration is 2s2, so that means 2 electrons we are going to consider with respect to per beryllium. So the 2s orbitals of the two beryllium atoms will overlap, resulting in the formation of two molecular orbitals, sigma 2s and sigma star 2s. Okay, next thing is मुझे 4 इलेक्ट्रॉन अरेंज करना है total, 2 electrons per beryllium, so 4 electrons for 2 beryllium. So we say over here 2 electrons each occupy sigma 2s and sigma star 2s. Electronic configuration में we have additional sigma star 2s2. Bond order, that star है मतलब anti-bonding, so 2 electrons goes into anti-bonding, so we have 2 over here, so that comes out to be what? 0. Okay, bond order is 0, so there is no bond, so that means the molecule does not exist. Okay, beryllium molecule does not exist. Magnetic property hardly any relevance. All electrons are paired. It is diamagnetic, लेकिन उतना ज़्यादा importance नहीं है क्योंकि the molecule does not exist. यानी इससे आपको एक और बात चलती रहेगी दिमाग में. It's exactly similar to what? Yes, He2. Okay, helium में भी मैंने वही बोला था, लेकिन helium was 1s, beryllium is 2s. यानी इस तरीके से you can relate hydrogen related to lithium and beryllium related to helium, and therefore we say helium and beryllium are monoatomic. क्या है वो? Monoatomic. Diatomic does not exist. Alright? So please have a look at the beryllium molecule, every one of you. So in this way, in this first part of containing 4 molecules with minor changes, जो मैंने आपके सामने करके दिया है, ओके, आपके सामने किया है, इसलिए आपको तसल्ली होगी कि हाँ, ज़्यादा कोई डिफिकल्ट नहीं है. एक बार हाइड्रोजन समझ में आ गया तो माइनर चेंजेस करेंगे तो हमें हीलियम, लिथियम और बेरिलियम तीनों समझ में आ जाएगा. ओके, यानी हमें लगता है ऐसे कि 4 मॉलिक्यूल्स पढ़ना है, लेकिन एक्चुअली एक पढ़ो और 3 फ्री. ओके, ऐसा ऑफर चल रहा है यहाँ पे दोस्तों. ऑलराइट, सो दीज आर ऑल द 6 पॉइंट्स, ओके, विद रेफरेंस टू दीज मॉलिक्यूल्स. अभी जिस तरीके से मैंने ये 6 पॉइंट्स बताया था हाइड्रोजन का, एंड देन माइनर चेंजेस, एंड वी कम टू द रिमेनिंग मॉलिक्यूल्स, द 3 मॉलिक्यूल्स. सिमिलरली आई एम गोइंग टू एक्सप्लेन यू द मॉलिक्यूलर ऑर्बिटल डायग्राम ऑफ हाइड्रोजन, and on the basis of that I will show you the molecular orbital diagrams of the remaining 3 molecules, that is helium, lithium and beryllium. So my dear friends, all the 6 points are being cleared with respect to the 4 molecules. Now the 7th and the most important is the molecular orbital diagram. Okay, I will show it in front of you how to draw it so you understand very well. Okay, how exactly the molecular orbital diagram is drawn. Okay, this is a very plain whiteboard you can see. So slowly and steadily, step by step, I will show you how to draw the molecular orbital diagram. So we begin with, first thing is, we're going to draw this vertical line. Again, this is with respect to what? Energy. That is the first thing that you need to remember. Okay, it's always with respect to what? Energy. Now, next is, we are discussing right now hydrogen molecule, and from hydrogen we'll be discussing about helium, lithium, okay, as well as beryllium. So on one side will be atomic orbital, on the other side also we have atomic orbital, and at the center we have molecular orbitals. Okay, ये याद रखिएगा आप लोग. Okay, the arrangement is on one side atomic orbital, other side atomic orbital, both of these overlap, and at the center there will be molecular orbitals. So because we are discussing about the molecular orbital diagram of hydrogen molecule, so atomic orbital of hydrogen, atomic orbital of hydrogen, and here molecular orbital of H2. Okay, now we will be showing the orbital over here. So atomic orbital we have is, it's only one orbital, so we show it as sigma 1s. So this is, I'm sorry, it's only 1s of atomic orbital of hydrogen. Now what we have to do is, the other atomic orbital is also of the same elements, because it is homonuclear, So please make sure that you are going to draw it in such a way that it is going to be having the same energy. Okay, please remember that I don't have a scale right now, but then you please understand that they are all at the same level of energy because the elements are same, electronegativities are same. Okay, so energy will remain same. ये आपको याद रखना है. ओके, यहाँ पर और यहाँ पर अगर दो अलग अलग एलिमेंट्स होते तो फिर ऊपर नीचे हो जाता था उनका एनर्जी लेवल. ठीक है, क्योंकि इलेक्ट्रोनेगेटिविटी में चेंजेस आता था, लेकिन यहाँ पर ऐसा नहीं है. ओके, तो ये याद रखिएगा आप लोग. नाउ दिस इज ऑल्सो 1s. So these two will overlap, resulting in the formation of two molecular orbitals. One of them will be bonded and the other will be anti-bonding. Bonding का मतलब energy is less as compared to the corresponding atomic orbitals. तो मैं ऐसे बताऊंगा. Okay, this is the way. और दूसरा होगा anti-bonding, so उसका energy level will be higher as compared to the corresponding atomic orbitals. So this is the way it is going to be. So this is sigma 1s and this is going to be sigma star 1s. Okay, this is the structure. ठीक है, अभी electrons arrange करना है. Now please remember my dear friends, many times the mistake which is being done is the students are going to show the electrons in molecular orbital. That is this center. Okay, यहाँ पे दोनों आजू बाजू में खाली ऐसे होता है, कई बार ऐसा होता है. ये दिमाग में ऐसा भरा है ना, molecular orbital diagram. So atomic orbitals are vacant, okay, and molecular orbital is perfectly filled with electron. कैसे possible है? Okay, so please be very clear. First you fill up the electrons in the atomic orbitals and then you fill up the electrons in the molecular orbital. Alright, so 1s1, you know that very well. This is also 1s1. Now both of them is going to pair up, which I have already told you. It's always going to be from lower to higher. तो इस तरीके से देख लो आप, sigma 1s2. Okay, this is what is the electronic configuration because rule मैंने बताया था आपको, the filling up starts from the lower energy level and electrons will not go to the higher energy level till the previous energy level is completely filled up. Okay, इसलिए ऐसा नहीं दिखाने का एक इलेक्ट्रॉन नीचे और एक इलेक्ट्रॉन ऊपर, नहीं. Okay, so both the electrons will be down. So this is, my dear, the molecular orbital diagram of hydrogen molecule. So please have a look at it and then I will show you the next one, that is helium. Alright? Okay. So we now go into the next one and that is helium molecule. बहुत simple है. So atomic orbital of helium on one side, atomic orbital of helium on the other side and molecular orbital of He2 at the center. Next is 1s में there will be a pairing taking place. There is a pairing taking place over here. It's 1s2 है helium का electronic configuration. So total there are 4 electrons. So left plus right is equal to center. ये formula याद रखेगा. So left में 2, right में 2. So that is left plus right is 4. तो center में भी 4 होने चाहिए. So 2 electrons are going to be in bonding. So other 2 electrons will be in anti-bonding. Alright, तो देखा आपने कितना minor changes किया है. And from this minor changes, from hydrogen you got helium. Okay, it's a life proof over here. Okay, so if you understand one molecule, the other molecule becomes very easy. So please, my dear friends, have a look at the helium molecular orbital diagram. Alright, we go into the next one, and that is considered lithium. Li2. Now one change I will do is, I write down here 1s, here also at the same level 1s, but here I will write down as non-bonding because we are only going to consider the valence shell. और फिर यहाँ पर instead of 1s I will make it as 2s. Okay, you can show 1s also, दिखा सकते हो, लेकिन I want to keep the diagram as simple as possible. तो 1s दिखाइए दोनों बाजू. Okay, यहाँ पर changes और वो क्या changes आएगा ये आप जानते हो अच्छी तरीके से. This is lithium, this will be Li2 and this will be Li again, the atomic orbital. So it is 1s2, 1s2, and 2s there will be only a single electron. Here also in 2s there is going to be a single electron. और मैंने बोला है फॉर्मूला, left plus right is going to be at the center, so that is 2 electrons, and इसका मतलब ये है कि यहाँ पे the sigma star 2s orbital is vacant. Sigma star 2s molecular orbital is vacant. Sigma 2s में 2 electrons हैं. So now I hope you understand this. Once again you can check it out. Confirm हो रहा है ना आप लोग को कि small changes करते हैं and we get the next molecules. Okay, including the molecular orbital diagram. So please have a look at it of lithium molecule. Alright, we go into the last molecule under this part, the first part. Yes, you understood this, and it is beryllium. तो beryllium में this part is common. सिर्फ यहाँ पे क्या आएगा? 2s2 आएगा, यहाँ पर 2s2 आएगा. Alright, so 2 plus 2 is 4. So I'm having 2 electrons over here, 2 electrons more over here. तो ये देखो हो गया. Within few seconds, एक molecular orbital diagram मुझे मालूम है, तो दूसरा तुरंत मिल जाता है. देखो ये. Okay, so this is about the molecular orbital diagram of beryllium. So this is Be2. Alright, this is the molecular orbital diagram of beryllium. So in this way, my dear friends, I have discussed with you the first part containing 4 molecules: hydrogen, helium, lithium and beryllium. मैंने इस तरीके से आपको पढ़ाया. चारों मॉलिक्यूल्स अलग अलग पढ़ाता था तो शायद आपको ये बहुत ज़्यादा लगता था, तो मैंने ये कोशिश किया कि चारों मॉलिक्यूल्स को इंटीग्रेट करूं. ओके, एक मॉलिक्यूल पहले आपको समझा दूं अच्छी तरीके से, एंड देन ऑन द बेसिस ऑफ द फर्स्ट हाइड्रोजन मॉलिक्यूल आई मेड सम माइनर चेंजेस so that you can easily understand the remaining 3 molecules also. And I am very confident you have understood all these 4 molecules, and I am very sure, okay, आप बोल रहे होंगे कि ये काफ़ी easy है. Okay, अगर पहला समझ में आया तो बाकी का बहुत easy है.